Hello, hello. Welcome everyone to the Moldex 3D webinar series. My name is Ian Mitsui. I'm an application engineer from the Moldex 3D North America office here in Farmington Hills, Michigan. And today we'll be gaining insights to the black box of material properties. We'll be looking into the effects of these material properties and how we go about characterization. So today we're going to be going over some of the key factors of materials in the injection process. We're going to be testing the capabilities of thermoplastics, including viscosity measurement at various shear rates, PVT measurements, some thermal properties like heat capacity and thermal conductivity. We'll also be going into some of the advanced measurements we do, such as crystallinity and viscoelasticity tests, as well as some of the details of testing for thermoset and EMC materials. So there are many key successful factors that contribute to molding quality, and today we're going to be focusing mainly on conventional injection molding. As material flows through the mold, we're going to have a viscosity or a velocity and shear profile. The shear profile is going to induce temperature differences throughout the mold. This in turn is going to cause different shrinkage rates in different areas, and that is largely where warpage comes from. It is important to have accurate material properties, which allow us to predict patterns where we can see where this warpage is going to happen. The core benefit of simulation is that it prevents us from running into some of these molding defects we see down the line, like splay, void, gate blush, flash. We could change our tooling design before it's built to reduce physical iteration. Here are the 5 key factors that affect most conventional injection molding processes. We have viscosity, PVT, heat capacity, thermal conductivity, and mechanical properties. All of these together fit into our mass balance, momentum balance, and energy balance equations that are the general guidelines for how most of our simulation is run. In more specific applications like thermosets, we also have our thermoset conversion balance. But again, the factors that go into this are viscosity, which is essentially the flow resistance inside the mold. This is going to be highly related to the filling behavior we're looking for, any short shot behaviors, weld line positions, filling and packing pressure, as well as the clamping forces. PVT is largely related to the packing behavior. It is essentially the relationship between the pressure, specific volume, and temperature, and many of our shrinkage and warpage related issues are going to be determined by understanding the PVT relationship. Heat capacity and thermal conductivity are both thermal factors. Heat capacity is essentially how much energy it'll take to increase or decrease the temperature of a material, and this is going to affect many of the cooling analysis we're going to do. It's very related to the heating cooling behavior of the part, the temperature distribution, and the cycle time of the part. Thermal conductivity is that material's ability to relinquish that heat back. And mechanical properties such as Young's modulus, Poisson ratio, those all have a big impact into going over some of the post-injection process stresses that can accumulate.